many of you know that I am a Forest Service employee. I am here tonight, and the work that I'm showing here, all the data, all the photos belong to me. So any analysis and opinions that I may express are mine and not representative of the Forest Service or the USDA. So cleared my conflict of interest there. I also want to, before I dive in, I want to take a moment and just acknowledge that the land on which I'm focusing on in this presentation, the land that we're on right now, this is unceded ancestral traditional territory, indigenous people. So I went to nativelands.ca, I believe is the website, and it's really interesting because you can look at the territories, the traditional territories on which you zoom in somewhere. So this area where I'll be presenting on in the lava fire and the southern end of the West Mountain is traditional nomadic territory of the Shoshone-Bannock, the Cayuse, Umatilla, and Walla Walla tribes. There's kind of a crossroads between usage. This particular area is in the Payette River watershed, and so you can extrapolate that this was once salmon spawning habitat in exchange for them. Okay, so I'm going to set my timer, keep track of my flow. And I'm going to begin by just sharing some photographs, some scenes of the post-fire habitat as I observed it this spring. Okay, we're clicking if I need to.
There we go. Oh, yeah.
Oh, okay. So for me, I have been in post-fire habitats frequently, but not so much forest environments that have burned. And so it's a little bit shocking to have not been in this environment, but be accustomed to traveling in really green, lush, whatever kinds of environments that we go and recreate in, and then travel out into this area that has experienced intense fire and to be surrounded by so much ash and char and death. And so I wanted to kind of close out this first little photo session with what else is kind of encouraging also to see the regrowth, the emergence in the spring. And I feel like wildflowers emerging from ashes is kind of the quintessential symbol of hope. So being a botanist and taxonomist, I'll just share. So top left, left to right, top to bottom is Figueria granite Flora. There's an Ammophila pedunculata, Scutellaria, and Vestifolia. Actinosperm americanus, which shouldn't be cat 5, actually, yeah, it is cat 5. Americanus, Carpia flagella, Penstemon gardneri gliding horizontal. Just a artistic selection of native forms that I observed. So I'm going to introduce the lava fire and what this event was and what is kind of significant about it. So it started on September 2nd. I think for those of us who were in Boise last fall, we probably all remember the Valley Fire that started in early October and burned really fast and really close. We had dozers and drip torches and aircraft flying right over top of neighborhoods. And I think for a lot of people, that was probably a little shocking, a little jarring to experience that up close. For how fast the Valley Fire spread, we as in the federal government, firefighting forces, had about as limitless, maybe I'm off, but from my side on the outside, we had about as limitless resources to fight that fire as we could possibly. The National Interagency, Fire Center is here, and we had an air tanker base right here. So we had an enormous amount of resources, and even then, that fire was spreading really fast. They were chasing it around for days. So with the lava fire, we have a similar explosive in the metaphorical sense, type fire expansion, except we have a landscape that is a little more remote and there's a lot more fuels. This is forested environments. And what seems to be happening in our climate here in southern Idaho, this intermountain region, is that we have this long period of summer drought. And spring might be great, or it may not. We have this long period of summer drought where fire danger and the rate of fire spread gradually increases. We have firefighters all over the West and here in Idaho and variously controlling things. But when we have a fire that starts in this late summer period, and then we have a wind event, that is the recipe now that we have for this exponential, really rapid fire growth. So what I find kind of remarkable is the best I could find for the acreages for each day that were reported in social media. We had the highest rate of fire growth, averaging 1,080 acres per hour for 24 hours continuously. Now, that's just my mathematical extrapolation, but if you look at the daily change, that's essentially what we had. And I'm going to back up to this photo here. We have a lot of black timber in this view. Almost everything where you can see yellow trees, almost to the farthest horizon, not to the way farthest horizon, way, way in the distance, but pretty far back in the horizon, everything between the viewpoint and there is about 1,080 acres. Georeference this image on Google Earth to give a visual comparison of all of this in 1 hour, lighting up. And I took a moment, and let's take a moment again really quick, but there's not too many trees that are still green in our view. So we have a really high percentage of canopy kill. So cold weather and rain pretty much is what put a stop to this fire. So that 98,000 acres, it's a pretty big area and a pretty big elevation gradient and a wide variety of plant communities and habitat types that were variously burned. For the reconnaissance and analysis and the ecological filters that I'm going to be talking about, my focus is actually going to be on this area here that outlined here is AOI. And that is kind of the lower end. So, beyond Forest Service, I was confined to Forest Service boundaries. But I find that this is also a really dynamic habitat because it's the ecotone between the shrublands, the sagebrush steppe, and the forest systems, the ponderosa pine, and we get into all these other types. And some music conifer forest. We have larch and grand fir up here, lodgepole, so it grades into fire adapted forest types. So having it burn is part of a natural process. And I don't want to get into it too much, but there is some discussion about, and there's a lot of sentiment among the silviculture folks, that the severity of the fire within the forest types is skewed all towards the severe and moderate severity, which I'll talk about here briefly. So in my reconnaissance, and my background is in floristics, which is really a descriptive taxonomy of distributions and species, which would assemble in communities. So taking that background, I really wanted to be able to go out here and interpret without collecting data, right? Because it's just me. I don't have a team. I can't do transects. We don't have the time and the resources to really quantify this. I have to do this really quickly. So I wanted to be able to travel around in this post-fire one, it's in the winter, and understand and try to interpret what the processes were and what the different types of patches and heterogeneity in that interface between the shrublands and the forested environment. So when we describe plant ecology, there are many, many types of filters that affect where things grow and why they grow there. I've selected 5, which I think help tell a story. And before I go into describing sites that I visited and showing photos, I want to just talk about how these relate. All right. So solar radiation and how it relates to topography. This is something that's been really interesting to me as a GIS technician for years now, and I haven't been able to apply it. And I could be wrong, but I haven't seen this concept show up too much in literature. But what I've done is I have used a tool in our GIS which calculates solar radiation based on the topography. So we often recognize in plant ecology that slope aspect and slope steepness really affects your community type. And so I've been working on this idea that we can quantify that by putting a number to it. We can quantify that effect, the slope aspect and the slope steepness, by putting some kind of a number to it. And the number that I found is kilowatt hours per square meter per year, which is a little abstract, admittedly. This originates from, I think this tool, this unit is really related to like solar farms and solar output that like you put on a building or you build for commercial purposes. But I think it applies pretty well. So I ran a fairly simple statistical test using canopy. So percent canopy is a raster data layer, some technical things that the USGS produces, and they update most years. The year that I used is pre-fire, so 2023 for the canopy percent. And topography doesn't change too much from year to year. That's pretty slow. So I had pretty detailed elevation data, and I overlaid the solar radiation calculation with the canopy, and I plotted it here according to the units of energy. Yeah, so I clipped an area from within what is the lava fire now. Representing about 25,000 acres. And it's an area where there is a mosaic of forest and grassland, shrubland. And it's a pattern that repeats. It's really interesting. But it also, when you just look, or you can on Google Earth, you can see that that pattern kind of follows topography. And some places it also does not follow topography too well. And what I found, simple ANOVA, is that it is highly statistically significant. So solar radiation is a great predictor of whether a piece of ground is going to be non-forest or some spectrum of forest. Another approach to looking at solar radiation is how canopy from the forest affects all of our understory diversity. And so what I'm providing here is a really broad look. You know, you can go to your favorite, I don't know, spruce forest interface and find a high diversity in that environment. You can find a lot of really interesting plants, but compared that to the shrublands and the amount of heterogeneity we have in shrublands, the alpha diversity, the total number of species, tends to be lower in our forest environments. And this would broadly, bear with me, apply to our forest types in this area. So, and there's quite a few forest types, but from the ponderosa pine forest to Doug fir and the lodgepole and these other types of the higher elevations. And this I'm drawing from literature, and I'm presenting it here because I also observed this in my field visits. And again, I'm not quantifying this. I wasn't able to, but this is my observations, which seems to be supported by literature, in that the number of different species I would see in what was canopy, that's all burned now, but what was canopy tends to repeat themselves. The species I would see would repeat themselves more frequently than those burn habitats in a non-forest environment. And I'll kind of put a caveat to my statements here on this slide, in that I'm confident that this relationship holds true in temperate summer drought environments. We go to some other ecosystem, we go down to Chihuahua desert or something, this might be different. I haven't looked into that.
What did you say data diversity was?
So, yeah, good question. Thank you for speaking up. So beta diversity is the idea of turnover. So you have two groups of species, you've got two lists of species, and beta diversity is the measure of change from one list to the other. And so when you have a high beta diversity, that means that they're dissimilar. And then alpha diversity is just the total number of species that occupy a habitat or an area. Yeah, so I think the key takeaway here is that the changeover from a shrubland environment to a forested environment, we have a whole other suite of species which are established, and there's a seed bank, and they're growing in these shaded forested environments versus the shrubland environments. And that's useful to think about if we are talking about our landscape changing, like if we're going to lose the amount of forest cover we have. Like we talk about climate change and forest shrinking. Well, those margins where the forest may be shrinking, that's the edge where previously it was one set of species and now it's open, and so we're opening up the space to a whole different set of conditions. So adaptive controls, it's been a really fun, interesting thing for me to follow through the years, through my geography, this concept anyway, through geography and through my master's in botany. Krugerberg, Krugerberg, I think his name is, has an interesting older text on plants and geology. We may be familiar with this concept when we're talking about calciphiles, or if we're talking about plants that are ultramafic. I can't think of the other term. What is the California plant?
Serpentine.
Serpentine, thank you. It's those conditions really exemplify the concept of adaptive controls. In the lava fire area, it's a little more muted, but it's still quite apparent. And so attempting to demonstrate some community differences. Say we have a uniform slope, so the solar radiation is the same across that slope, but we have differences in underlying structure in the rocks or the geology that then result in different soil, and then we have all these different communities that are represented. And so this process is contrary to previous slide I was talking about solar radiation organizing the landscape, because the influence of adaptive controls would override what the sunlight's doing. And so a really great example is if like you have a hill slope and the hill slope is south facing, and it's maybe predominantly dry grass or something. But then you have this band, this horizontal band across it, which is all deciduous shrubs. And, you know, it's like, well, where are those plants getting the moisture? Where, you know, it's really dry for some reason, and then you have this one spot that's different. And I'm gonna keep moving because I have some slides that actually show what I'm talking about a little better. So soil burn severity. This is really important post-fire during the closing down of firefighting efforts. They're on the forest, and the BLM has their process as well. But the forest will send out teams that travel around the different sites, and they assess. They have this criteria where they assess the soil and how burned the ground. So they're looking at, they do some imagery and they look at how badly burned the vegetation is, but they really want to know the process that's underlying the burned vegetation, and that would be by looking at the soil. So there's a technical manual. Hopefully maybe we'll get to learn how to do this next year and actually classify the soils by their burn severity. But there's definitions, and I've adapted those definitions, so I may not follow it exactly here, but there's certain features that the soil will have, or certain things that the soil undergoes or doesn't undergo, depending on the severity level of the burn. And a big part of what affects the soil burn severity is the fuels above the ground. So if you have grasses, if it's all just grass cover, like the valley fire, we have low weed things. I don't think we had too many. We don't have a lot of shrubs left down on our Boise foothills, do we? Yeah, so pretty fine fuels. And even though it burns fast and it's kind of scary, in terms of the soil, it doesn't burn that hot. It's not until we get timber or thick cover of shrubs that the fire can even burn hot enough to really affect the soils in this way. So at low severity, we have fine fuels consumed, seed bank mortality is low. It's pretty crazy because sometimes you go out to a post cheatgrass fire area, and weeks after the fire's out, you walk out there and you can pick up the seed still there, all intact. The surface didn't even burn hot enough to burn the seed that had fallen that spring on the ground. That effect can be patchy, so it's not necessarily uniform. You can have a little bit of kill in that top layer of litter. shallow roots are mostly intact. So with moderate burn severity, we have a little bit more uniform kill of the surface seed bank. And your organic matter starts to become burned off. And then with high severity, we have soil that's sterilized to some depth. We have a hydrophobic layer, so it chemically alters the surface of the soil so that when rain or snow melt is on that soil, it runs off, it doesn't infiltrate down. And the structure of the soil, so the horizons to whatever depth that heat reached, those horizons have been altered as well. So high burn severity in the soils can fundamentally alter the behavior of what plants can establish and grow in that setting. All right, so taking the soil burn concepts and applying it to what the lava fire actually did. I plotted out the severity by acreage, so that's the pie chart in the center. But what the pie chart, if you just look at it this way, it doesn't show the spatial arrangement of that severity. And I didn't have a really good way to do that for you in the slide. But basically, the high and moderate severity really concentrates around those fire adapted areas, the areas with fire adapted forest types. So while in a fire adapted forest type, we would say that having some high severity fire, having it burn really intensely, that's okay, that's patchy, it's adapted to that. But if we say most of it burns at high severity, it kind of raises a question of, well, is this, at what scale is it healthy and such? So there's some thoughts that I have about the fire ecology in the forest. So this is not an area that I looked at too much. But what is interesting to me also is when there's post-fire assessment and they're looking at the severity of the fire and they see these shrublands and these grasslands and we say, oh, it's low severity. The soil didn't burn very hot. Well, it can have a pretty profound effect on those habitats, even if the soil burn severity is low. So I put a selection of species on here, and they represent pretty wide range of fire adaptiveness and how they respond. We did have a small area of the fire burned in subalpine habitats. So if anybody has been up to, actually, has anybody been to Blue Lake, Snowbank Mountain in here this year? This
Yeah.
year?
Yes, or I've been up in that area a little bit,
This
yeah.
this year?
Yep.
So you saw the burned spruce and
Yep.
that parkland up, yeah. So we have some area. So the fire burned, and the way that the winds were blowing. Back up a little bit. Yeah, so we have this little trickle over here and here, and the fire blew all the way over top of the mountains. This is 7,000 and 8,000 feet elevation. So when I show that elevation profile, the winds blew it all the way over those subalpine parkland. This is lightly glaciated terrain up here, those high elevations. And it's also a little shocking because I've never seen subalpine forest that had canopy kill up there. For the scale of the fire, it's a pretty small area that burned this way, but it's still remarkable to see. Okay. Now, Artemisia tridentata, I'm not specifying varieties this evening, but it's very fire intolerant, so it has to reseed they tend to die 100% when there's a fire, a shrub fire. In the same or similar habitats, we've got bitter brush, the Fuchsia tridentiflata, which does have some resprouting, or the seeds, or I'm not sure if it's seedlings or if the shrub is resprouting, but I've observed shoots, many shoots coming up from the dead bases of bitter brush plants, but not always. It's around half, a third, or 2/3 of the shrubs I saw, so it varies a little bit. So it does okay on being burned, but then we have the chokecherry, the Prunus virginiana, and it goes bonkers after the fire. So you can see these charred areas, and I'll show you a little later. And the shoots are just coming up all over, and you can see the the altered soil. It's like white ash. You can see that, and the shoots are just coming right up from there. So it's interesting, the difference in fire response. Which kind of segues into what I'm trying to convey here. And it's traits that we would use for functional groups to understand where or why species are successful or not when we're looking at a habitat. And it kind of helps to understand, post-fire or what the history was of that piece of ground that you're looking at that led to the assemblage of plants that you're looking at right now. Why is it invaded? For example, why is this piece of ground really invaded, and yet I'm still seeing some native species here? That is something that I'm really interested in, and which I wish to convey in the course of this, is the persistence of those native species in the face of invasion. We have a synergy of different non-native species in and around the lava fire area. And it's hard to pick out any one of them that is like the culprit. There are some places where the skeleton, the rush skeleton weed, so Chondrolodontia, is just dominant. It's like just thickets of the stuff, and it's kind of scratchy. You wade through it, and there's not much else but the skeleton weed. And then there's other areas. It's interesting. I found some large populations of this non-native annual forest, so dianthus. And then there's also some I haven't put on here. There's more than I could even put on here. But each of these differs slightly in their traits that allow it to succeed and establish and outcompete sometimes the native plants. And so 3 categories that I think are really important for our native plants and our non-natives in this post-fire shrubland grassland setting is the fire response strategy, colonization rate, and their competitive function. Yeah, so is it a fire response we're talking about? Is it a resprouter? So I kind of illustrated that a little bit. Or in the case of sagebrush, is it an obligate reseeder? So is it reestablished only by seed? Is it starting from zero? And how aggressive is a colonizer? Is it cheatgrass? We know, or many of us know, that we're familiar with. I mean, the name cheatgrass is because it cheats the season. It starts the race before all of our other plants. So colonization rate really high in that example. And competitive function. So with native plants, they tend to be, at least in these landscapes, I'm finding that they tend to sort out as facilitators. So the presence of, one native species. So if I go somewhere and there's a bunch of sulfur buckwheat, I don't see evidence that it's excluding, it's gonna exclude, it's just gonna continue spreading and take over all the space until something else that's equally aggressive takes it on. It's not really what we're seeing with the natives so much, but with the non-native species, they tend to be like resource deniers. So they will monopolize the resources. And so the functional groups that I was just describing, and I picked 3 categories. There's many others. You can look at whether they're annual or perennial, and there's other categories looking like that. So just those 3. In any case, that really feeds into this idea of resistance and resilience. And there's a really great manual. The Rocky Mountain Research Station has put out a manual that really dives into detail, focused on sagebrush restoration and sage grouse habitat. I'm applying this a little higher in the elevation range than what they designed it for, but I think it fits perfectly here. I think that concept of resistance and resilience applies pretty broadly to ecosystems. So resistance being the capacity to retain its structure and function against stress or disturbance. So I'm attempting to illustrate this by a disturbance event. So fire, my little fire icon here. And then the response afterward, the resistance afterwards is what effect does that event have? So a habitat that has really low resistance in our grassland system, and I just picked a number. This is qualitative, but we'd have a loss of maybe 1/3 of the cover of native plants. So it's not total loss, but it's a significant loss. So that if there's another event and that piece of ground loses another 30%, we have this successive process where it's gradually degrading until it's something else entirely. With resilience, it's the idea that after a disturbance event that may take the community into a completely different state, different composition and structure of plants, and eventually through successive processes, it returns back to the state that it was. So a really good example of this would be the Mesic conifer forest. So the idea being that Doug fir and Grand fir, when it all burns and all the canopy's gone, the trees may not come back immediately. It's going to be something else that comes back, shrubs and forbs, but the productivity, the amount of biomass is going to be really high, which then facilitates seedlings of these conifer species, which then grow under the shade of this sterile stuff. And so through a successful process, we get a return. So that would be a high resilience. All right. So I have 4 sites that I visited. And by site, I don't mean like a transect or quadrats. These were areas that I toured and was documenting the species and just qualitatively observing the abundance of different species and these functional groups and trying to identify what the processes were. So site 1 is a dry meadow area right on the edge of the lava fire, and it's surrounded by ponderosa pine forest. And the elevation for continuous ponderosa pine forest is pretty low here. But what I found in this little patch was that it was pretty highly invaded. And what was strange to me is that I was traveling through, even in the burn, I walked through about a mile or 3/4 of a mile through burn. And it was not highly invaded, so there's this little piece of ground that has somehow been colonized and largely taken over by rough skeleton weed. But the propagule source, so there's no continuous corridor that I was able to observe, so it's interesting for me to see that there's this little non-forest island that's separated, so the dispersal different distance seems to be fairly high, and then where the skeleton weed is able to establish, it then proliferates locally. The forbs that I did see, the native forbs, tended to be deep-rooted perennials. And my best guess is that well, not guess, the deep-rooted spring ephemerals would have escaped the lava fire, particularly if it was low intensity, because by September, the balsam root's all dormant. The seed would have dispersed. A lot of our lomations, a lot of our really showy and fun seed native spring plants would be just completely dry and crispy and all crumbled up anyway by the time the fire came through. So they're persisting. But the fine fuels, like I said earlier, the fine fuels in this environment would have been burned off. The native or the non-natives that were here beforehand are still here after the fire. And the other thing I want to point out, I almost missed it, I almost forgot, was that there wasn't evidence of bunch grass in here. I didn't see like very much bunch grass, native bunch grass. And there's no burned stump. So I've been places where you get down on your hands and knees and you look real closely, there'll be little burned root crowns and they'll be all over. And there wasn't any of that here.
And I wanna go home.
Okay, site 2. So another location that I selected, I want to illustrate, I chose this spot because there was a lot of variation in the ground. So some areas were really rocky. And it's kind of messy, and I apologize, it might be difficult to see, but there's a lot of yampa. It's this field of yampa. I can't think of the scientific for Paradiridia. Yeah. And Allium acuminata. It was an interesting field of maybe an acre, half an acre or so, of primarily those species. And there was very little non-native plants here in that patch of ground. And I walked a little further nearby, further as in 50 yards, 50 meters or so. And it gets deeper loamier soil. And there we have a whole bunch of skeleton weeds sprouting up for the season. So it's in here also, but then I reached the top of the ridge and this other frame here, we have a really high cover of the deep-rooted forbs again, but this time there's no invasive species in here at all. Let me take that back. There are, what did I say here? There were some Poa bulbosa, and Poa pratensis. So they are non-native, they do compete. On the scale of our invaders, they are prolific, they are destructive, but they're not as bad as the skeleton weed and some of the others. On their own, they're not as bad, maybe. In any case, we have a patch of ground, 2 patches of ground that are quite different in their cover, but aren't very invaded when there is still a pressure here. There's some invasive pressure. So the non-natives are establishing here, but for some reason, they're being, that establishment is prevented. And I don't believe it's because there isn't a seed rain. It isn't because the propagules aren't coming here. So site 3 is a little higher, but it's a little further away from the mountain, the height of the mountain. So we have a little bit higher, but also a little bit drier slightly drier, very subtle difference. But it's predominantly grass shrubland mosaic with a few conifer stringers. But here is an example that I mentioned earlier of the denser shrub providing fuel. And so in one little patch, the fire burned hotter. We have a bit more of that white ashen soil, possibly some hydrophobic formation, and yet all of that green coming up there, that's all the chokecherry. And because the soil burned really hot, if there was a seed bank in there, that seed bank would have been sterilized. So if we had a whole bunch of invasives that had somehow come into that patch of ground before the fire has killed all that off. And yet the shrubs are able to still come up. And so it's this little patch of ground that's able to sustain itself post-fire in an otherwise dry, hilly landscape. And then the panel on the right here, this is some of what I believe is that edaphic control that I was describing, where the slope doesn't, I mean, in a small space, you have this really defined difference, and it's really about the soil characteristics. And we draw that back to, well, why are the soil characteristics different? I had a debate with a colleague who really thinks that this is the result, this on the right, is the result of restoration management and experimentation. And I know that, for example, in the Boise forest, here in the Boise Front area, there are some areas where they have put, they've contoured into the hill slopes, and they've planted things, and it's still visible in places. And so she was thinking really strongly that that's what happened out here. Well, I don't know, and I hadn't spent a whole lot of time researching the site history. Sometimes when you try to dig for older restoration projects, you can or can't find information on it. In any case, for the purpose of post-fire plant ecology, that history of management, I don't think is as important as understanding the processes that are happening now and what plants are going to come back in these different patches. So on the right, there's a whole ton of allium and humanatum, and that was the dominant patch again for like an acre or so. It stank, even though they hadn't. It smelled like onion. It just stank as if it was great. It was pungent, especially when I sat down to take some photos and crunched on some of them a little bit. But then you have the higher productivity ground higher up on the hill slope. We have a lot more biomass, even post-fire. And I clipped it off, but there were shrubs in there, and the shrubs have burned off. It may have been bitter brush, or which doesn't resprout too well, but can. In any case, some of the structure is lost. And what I've seen in that higher productivity patch of ground in that panel is that there was a marked increase in the number of non-native plants. So rush skeleton weed was really establishing in that higher productivity patch, but not in that stony or shallow soil area. Okay, and site 4 was an attempt to understand what conditions might have been like before the burn. So there were some areas in similar elevation, and I picked this area. It was about a mile or two loop hike that I walked. So I traveled through these different habitats. So here's one particular view, and it kind of characterizes the process I used to make these observations. Was just traveling through all these different habitat patches and recording the species I was observing and noting like if there was any variations. So behind me, not visible, and I didn't photograph it or didn't make any slides, but there were patches of upland bitter cherries on really, really dry ground. And that's a deciduous shrub that we often think with like kind of riparian or kind of like more mesic environments. But out here, there it was, hanging out in the open with like some bitter brush and dry and like cheatgrass and dry and weedy stuff. And I'd also observed that outside of the burn area with blue elderberry growing up that habitat. So there's some quirks in the local ecology, I think, and the chance establishment that would allow the more mesic shrubs to establish in really dry patches. Anyway, so this reference site, what struck me was that the riparian areas, so that not the slopes that have the shrubs so much, but the areas that are actual drainages, even though the drainages are seasonal, are really dominated by hawthorn. And I have some property out by up towards Idaho City, and I've hawthorn. It's native and it belongs here. But what's notable, I think, is that it dominates in the riparian areas, and it's not as palatable by livestock, I will suggest. And so I think that my working observational hypothesis is that, yes, this is an area that has been grazed for a long time. And so we have a relic, a shift in the native species towards that grazing pressure. The dry patches, so the really dry patches tended to be rocky, thin soil, similar as the previous site, where I was talking about the allium. And the intermediate habitats that were kind of productive were really, really invaded out there. So this is the unburned area adjacent to the lava fire. Had Medusa head. And I think I may have seen ventinata. So another one that they're really worried about, another invasive grass. There was dense stands of skeleton weed and dianthus and all kinds of things. And yet there were still these little native refugia in these different patches of soil, which I think was really interesting. Yeah, so high beta diversity between soil ecotypes. Okay. So putting my field sites together and all the observations, I came up with these, right? This is professional assemblage of the community species. I did, often when we do community classification, we have a pretty complex set of plant occurrence and a cover and species presence and such. This is just Jessica Irwin, having looked at a lot of literature, putting these together. I actually plugged this into, I plugged my whole presentation and the literature for soil burn severity. I plugged a lot of data into an AI chat session. And I asked it to analyze the resistance and resilience and whether they're going to be stable. So this is the resulting table. I didn't take it verbatim. I did adjust a few of the things. So this is me steering the computer model for what makes sense. And it was interesting because that computer model largely confirmed what my biases were always pointing towards in these community types. But the conclusions that computer and I have are that some of the habitat types are stable and some are not. And that variation in patch over space means that we can't really apply a single approach to our shrublands across large areas and have it be very effective or very valuable. There's going to be some of these patches that don't really need restoration or certain management prescriptions that we may apply that may be needed elsewhere. So shallow rocky xerophytic sites, we may have some. So with each of these first three that I'm saying are stable, there may be a little bit of non-native establishment that wasn't there before. So we may have some change, but I'm calling it stable because by and large, the opinion is that the ecosystem function is going to be stable. So the pollinators and the wildlife habitat and the insects and the bugs and all of those things are going to largely remain intact for these ecosystems. So shallow rocky sites, four islands, and deciduous shrub thickets. The Mesec ponderosa pine forest is a somewhat successional system. And so prediction is that the higher productivity will eventually lead to the recovery of that type of habitat. And the more productive mountain shrub grasslands, these are areas where we might have onion grass and the arrowleaf balsam root. We're going to have Ripinus and Helianthella, Uniflora, dropping names. Those are going to be more at risk, as are the xeric shrubland. So in the reference site, I failed to mention, there was a sagebrush island that I investigated. It was about 7 acres. So I did go back and map it on, you can spot the sagebrush once you know what to look for on Google Earth. So I mapped it out at 7 acres. In any case, anywhere that may have been a sagebrush island pre-fire in the lava area is now at high risk of conversion into a non-native forest grassland, as is the highly productive mountain shrub grassland mosaic. Also something to pay attention to in the lava fire area, these lower elevations, is that the dry ponderosa pine forest may also be at risk of type conversion. If we consider that establishment of the non-native plants, the skeleton weed and the cheatgrass and such, is going to, if it's going to be outcompeting ponderosa pine seedlings, then we have a situation where the original or historic community type may be trapped into a new cycle. And then non-native pulp grassland is pretty stable, so it's resistant to change. So if we do management actions and we put energy, we pour herbicide into this habitat type, it's going to take a lot of effort to pull these already invaded areas out of that state into something else. All right. So what do we need out here? Well, I haven't mentioned rare plants at all. But within the burn area, there are what we call EOs. So there are EOs of Ptolemy's onions, Allium ptolemyi variety personally. But historically, this area isn't well botanized. There is a survey history associated with like timber sales. So whenever there's a timber sale, the botanists are required to assess and actually go out and clear patches of ground to ensure there aren't rare plants. But it's pretty spotty, that history. So there's a lot of ground, particularly in these at-risk communities, that are promising locations for the Ptolemy's onions. And then there are a few other species which could be out here, but because the area hasn't been well surveyed, we don't have any EOs. My assessment is that, like I listed the Phacelia minutissima, the occurrences that we have in southwest Idaho are pretty far and few between. But I do know that just over the border on the Payette Forest, there was a young crew of interns that did find a population of Phacelia nudissima. So it's out here, and without getting off track, some dedicated surveys are really needed, and especially as a requirement by the forest, by the government. If we're gonna do anything to the land, if we're gonna put seed out there, or we're gonna put herbicide, we have to make sure that there aren't populations of these rare plants that we're interested in. We also need restoration activity of some kind, or weed treatment or something in those community types that are at risk. This area that I've been, so the non-forest communities, I didn't mention this, it maps out as around 2,900 acres. And it's, like I said earlier, it's this really patchy mosaic. So there's all these little patches that might be 300 acres here or 400 acres over there. It's really time intensive and expensive to perform any kind of restoration activity at scale that we're looking at here. So anything that would need that happens either needs to be coordinated with the federal agencies or led by the federal agencies. And I don't know for sure, because Jessica Irwin, forest botanist, is furloughed right now, but there is a pot of money for this right now. Hopefully it wasn't taken away to pay for, yeah, there's a pot of money as far as I know for post-fire restoration activity. We're looking at hiring a crew. Excuse me, the Forest Service is looking at hiring a crew next year to help with this. We also need some more quantitative data, right? So everything I presented is really Jessica Irwin's professional opinions. And some quantitative data will really help establish whether the claims I'm making are actually happening, whether we're maybe losing ponderosa pine, or whether those stony shallow soil habitats are actually stable. It would be great to know whether those trends are actually holding. All right. So if you are interested in a copy of this presentation, please email me. Also, I revealed that I made some use of AI. You can view the session, the main session, and I did branch off a few times because I was discovering some things along the way that AI was capable of. I didn't quite know. It's a very lengthy session. So if you want to see some details more related to the presentation, scroll all the way to the end, you'll get the most recent stuff. If you just want to see what kinds of conversations happen with AI, we'll start from the beginning. I'm uploading aerial imagery from Google Earth and asking the AI to interpret the vegetation communities, which is pretty cool. And then I'll put a plug in here for iNaturalist. So the link here is to my observations. But I encourage you all, when you go out on your nature walks and such, to take photographs and as detailed as you can and upload them. It doesn't have to be iNaturalist. I think the point is that we're putting citizen science to use. And researchers at PhD researchers increasingly are using citizen science data to publish papers. So it's a pretty great resource and a pretty great way that we can contribute. And special thanks to Boise Forest for including non-forest restoration in their NEPA and funding efforts. I see that I've gone long, so thank you all for your patience.
Thank you.